You are listening to SDO Isabela Radio-Based Instruction.
Learning never stops in Radyo Eskwela, your school on air.
Your partner in achieving fun learning experiences. Let's listen, enjoy, and have fun in learning mathematics. Stay tuned.
New year equals new life. Hello, grade 9 learners. Let's begin this year with new hope no matter how hard the past was. This is your school on the air in Mathematics 9. I am your radio teacher, Teacher Dayanara. Let's walk together for another mathematical journey. Are you ready to have another math lesson on the air? I am sure you are. Set up your mind, hand your pen and your learning activity sheet, and make sure that you are in a conducive place to be able to listen properly and understand well our lesson. As we begin our lesson, everybody say, I love math. Again, in our previous episode, we derived the laws on radicals. Learners, can you still recall these laws? Let's have a recap. What is again a radical? That's right. Radical is an expression in the form of nth root of a, where n is a positive integer and a is an element of the real number system. An example of this is the cube root of 8. 3 is called the index of the radical. It can be square root, cube root, fourth root, and so on. The symbol is called the radical sign and 8 is the radicand. There are laws on radicals. Before we can simplify radicals, we must know the different laws regarding this expression. Do you still remember these laws? Correct! The first law, we have the nth root of a raised to n equals a. The simplest explanation of this law is that if the index is the same with the exponent outside the expression, you can just cancel out the index and the exponent, so the answer is a. For the second law, the nth root of ab equals the nth root of a times the nth root of b. This is the most frequent used law in simplifying radicals. As we heard, we factored out the radicand. The third law, the nth root of a over b equals the nth root of a over the nth root of b. In this law, it came from one single fraction and single radical. Then, we express it separately. Then the last law is the nth root of n root of a equals nth root of a. In simplifying radicals, it doesn't enough that you should know all the laws. We must consider these three. First, removing perfect n powers. No prime factor of a radical that has an exponent equal to or greater than the index. Second one is rationalizing the denominator of the radicand. No radicand contains fraction or no radical in the denominator. If this exists, you need to rationalize by making the radicand a whole integer. Rationalization is process of removing the radical sign in the denominator. Lastly, reducing the index to the lowest possible order. Okay, learners, are you ready to apply the laws in simplifying radicals? Let's take this example. Simplify each radical. Number 1. Simplify square root of 25. Right, since 25 is a perfect square number, basically it is 5. If you multiply 5 by itself, it will give you 25, or if you square 5 that gives you 25, applying the first law, the nth root of a raised to a, we will express 25 as 5 squared. The index and exponent now is the same, therefore the answer is 5. Number 2 example, simplify square root of 63. As we know, 63 is not a perfect square number, so what do? Alright, we should factor out the radicand and one of the factors should be a perfect square number. So, what would be the factor of 63? Great! The factors of 63, wherein one of the factors is a perfect square, are 9 and 7. Square root of 63 will be expressed now as square root of 9 times 7 or square root of 9 times square root of 7. In this example, we're applying the second law. As you heard, we have a single radical which is square root of 9 that is equivalent to 3. There is no factor in square root of 7, therefore, our final answer is 3 times the square root of 7. Next, number 3 example, the cube root of 81. We don't have cube root of 81, hence we will factor out the radicand in such a way that one of the factors should have a perfect cube root. So, what would be the factors? Excellent! The factors are 27 and 3 since 27 has a cube root. Next, number 3 example, the cube root of 81. We don't have cube root of 81, hence we will factor out the radicand in such a way that one of the factors should have a perfect cube root. So, what would be the factors? Excellent! The factors are 27 and 3 since 27 has a cube root. We have the cube root of a 27 times 3 or the cube root of 27 times the cube root of 3. Getting the cube root of 27, that is 3 times the cube root of 3. Therefore, the cube root of 81 equals 3, the cube root of 3. Let's take another example. The square root of 18, x raised to 3 and y raised to 4. As you see in our radicand, there are variables involved. How do we simplify this kind of expressions? First, we should factor out 18. 18 is not a perfect square, therefore, we will find factors of 18 that is one of the factors should be a perfect square number. The factors of 18 are 9 and 2 because 9 is a perfect square number. How about x cubed? We will factor out x cubed. We will express x cubed as x squared times x so that one of the exponents would be the same as the index. Then y raised to 4 will retain since 4 is divisible by 2. We can directly simplify y raised to 4. Simplifying the square root of 9 times 2 times x squared times x times y to the 4th equals square root of 9, that is 3. The square root of x squared, that is x, and square root of y to the 4th, that is y squared. We will write them outside the radicand and those 2 and x will retain inside the radicand. Ergo, our final answer is 3xy squared, the square root of 2x. Let's have another. Simplify the square root of 60x to the 4th y to the 5th power. 60 is not a perfect square, but we can factor out 60 by 15 times 4. we can get the square root of x to the 4th power, then y to the 5th will be expressed as y to the 4th times y. Then we'll separate the terms that can be removed by the square root and those that are not. Let's simplify. The square root of 4, that is 2. The square root of x to the 4th, that is x squared. Y to the 4th, that is y squared times the square root of 15y. Hence, the final answer is the square root of 60x to the 4th y to the 5th equals 2x squared y squared times the square root of 15y. How about this example? The square root of 1/2. One thing to be considered in simplifying radicals is that no radicand contains fractions or no radical in the denominator. So, how do we simplify this kind of radical expression? Square root of 1/2 equals square root of 1 over square root of 2. As we observe, there is a radical sign in the denominator, which is square root of 2. We will rationalize it by multiplying the numerator and denominator by a radical that makes the denominator a perfect square number. What would be that radical? Very good! That is square root of 2. So, that square root of 2 times square root of 2 equals square root of 4, and now 4 is a perfect square. Let's multiply square root of 1 times square root of 2 gives us square root of 2, and square root of 2 times square root of 2 equals square root of 4. Simplifying these examples, square root of 2 over 4. So, the final answer is square root of 2 over 4. Last example. The cube root of negative 16x to the 6th power y cube z to the 12th power. You might wondering there is a negative sign in the radical, but that's okay. If the index is an odd number, then we can get the nth power. What would be the factors of negative 16? Yes, we can factor it as a negative 8 times 2 since 8 has a perfect cube root. X to the 6th power will no longer factor out since the exponent is divisible by 3. Same as true with y cubed and z to the 12th power. Cube root of negative 8, that is negative 2, cube root of x, that is x squared. Cube root of z to the 12th, that is z to the 4th, then the remaining inside the radical is 2. Hence, our final answer is negative 2x raised to y z raised to 4 times the cube root of 2. Okay, learners, did you follow the given examples? So, what are the things to be considered in simplifying radicals? Right! We should apply the laws on radicals by removing the nth powers, rationalizing the denominator, and reducing the index to the lowest possible order. Okay, I think you're ready now for your short quiz. Get your pen and a piece of paper and simplify the following. Number 1. Simplify square root of x raised to 5. Again, simplify square root of x raised to 5. Number 2. Square root of 63m squared. Number 3. The cube root of 125x to the 5th y to the 18th power. That's it. You only have 3 items to answer.
Ito ang bagong simula, bagong normal, bagong umagang parating. Ito ang tamang panahon upang maghanda sa bagong hamong haharapin. Hindi magbabago ang hanap mong pusong tumulong at ituloy ang ating misyon. Dahil anuman ang sitwasyon, tuloy ang edukasyon. Walang maiiwan, lahat ay aahon. Sama-sama tulong-tulong sa ating pagsulong. Anuman ang sitwasyon, tuloy ang edukasyon. Tuloy, tuloy, tuloy. Tuloy ang edukasyon.
Pilipinas sa gitna ng pandemya, tayo ay magsama-sama kapatid. Kababayan, dapat kang makialam. Halina at tulungan ang ating paaralan. Ipagpatuloy lang natin ang ating sinimulan. At sa bawat paghapang, bakit sa pangarap mong hagdan, ipalaganap ang pag-ibig at gintong kaalaman. Kahit sarado ang pinto, huwag tayong huminto. Dahil ang edukasyon ay higit pa sa ginto. Katulong ang bawat isa at pamahalaan. Ang lahat ng ito ay malalampasan. Taas yung kung haharapin ang realidad. Ating isigaw, sulong edukalidad. Sulong edukalidad.
Bago ang hanap ng pusong tumulong at ituloy ang ating misyon. Dahil anuman ang sitwasyon, tuloy ang edukasyon. Walang maiiwan, lahat ay aahon. Sama-sama tulong-tulong sa ating pagsulong. Anuman ang sitwasyon, tuloy ang edukasyon. Dahil anuman ang sitwasyon, tuloy, tuloy, tuloy. Walang maiiwan, lahat ay aahon. Sama-sama tulong-tulong sa ating pagsulong. Anuman ang sitwasyon, tuloy ang edukasyon. Tuloy, tuloy, tuloy. Tuloy ang edukasyon.
Pens up! Let's answer. For number 1, the answer is x squared is square root of x. Number 2, the answer is 3m square root of 7. And for the last item, number 3, we have 5x raised to the 6, the cube root of x raised to 2. Did you get it all? Wow, excellent! For those who got 2, good job. And for those who got 1, don't worry, let's make it better next time. And that ends our learning episode for today. For you to understand better our discussion today, you can answer the remaining activities given in your learning activity sheets. If you have queries and clarifications regarding today's episode, text, call, or message your math subject teacher. I'm sure they will gladly attend to your queries. This episode was written by Ma'am Leslie Ann Ballesteros Gamaru and the whole RBI production team of SDO Isabela for making the production possible. Again, this is your radio teacher, Teacher Dayanara, signing off and saying, sa SDO Isabela, #walang maiiwan, #we recover as one. Until next time!
Patuloy ang edukasyon para sa ating henerasyon.
Sagaan ang pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!